Okay, so today we're doing composition of functions. You can write f of g as like f of g, or g of f, like g of f. You might also see like this format notation where you put the g inside of the f, or this one where you put the f inside of the g. So whatever's right here, whatever's like furthest right is the one that's going inside, right? So composition of functions is putting one function inside the other. The one to the right goes inside. Okay, so let's take an example. Given f of x equals x squared minus 1 and g of x equals square root of x, find f of g of 2, g of f of negative 4, and f of g. So for this one, we want to start with g, right? I'm going to start with the inside, and we're going to put in a 2. So we're going to have g of 2 equals square root of 2. And then we put that inside of f. So we're going to put this root 2 inside of f. So f of g of 2 equals root 2 squared minus 1. So root 2 times root 2 is just going to be 2. And that just equals 1. So that is putting in a direct number. Here's another example of putting in a direct number, except for the format just looks differently. So you're doing the same thing, but it just looks different. So this time, remember, this one's on the right. So g of f, we're going to do f first because f is on the right. So we do f of negative 4 equals negative 4 squared minus 1. Be careful on your calculator because if you type this without the parentheses, it's going to give you negative 16. But a negative times a negative is positive. So 16 minus 1 equals 15. So we found f of negative 4, and now we have to put that into the g, right? So we did our first step, and then we're going to do our second step. So we do... I'm going to write this one different. I'm just going to write g of 15. G of 15 equals square root of 15. And then this one is tricky because there's no number. So instead of putting in numbers, you're just going to put in variables. So we're going to put g inside of f. So we're going to put this root 2. So this is f of x equals x squared minus 1. And f of g of x, right? Let's do different colors if you... Ooh, this pen works. So instead of an x, I'm putting in an entirely different function. So g of x is root x. So I'm going to square that minus 1. So everything's the same except for wherever there's an x, I'm putting in a whole different function. And then we just had to simplify the function. So we have f of g of x equals root x squared, just takes away the root, so we have x minus 1. Okay, so the important thing that we want to think about when we're doing this is the domain. So if we have a domain for these, for like this one in specific, right, we're left with variables. So if we were to do the domain, if we look at the answer, there's not really any limits, right? Like x could be anything. But when we look into the composition of what made it up, like this g of x, we have a square root, and we can't have a negative square root. So we want to think about, we always want to think about like where our values are allowed to be. So in this specific equation, our domain is x is greater than or equal to 0 because of this part right here. Right? We're not allowed to have negative square roots.
No.
So that's our domain.
Because if I remember correctly, negative square roots are like what? Imaginary numbers, no?
Correct, yeah. Okay, let's take a look at the next one. Okay, the next one is f of x is 3 over x squared minus 5. G of x is square root of x minus 2. So if you want to take a second and try that on your own, you should try that on your own. Okay, so we have the first one, f of g of 2. So we're going to have g of 2 first, the inside, equals square root of 2 minus 2, which equals 0. And then we have f of g of 2, or f of 0, equals 3 over 0 squared minus 5 equals 3 over 5. Oh yeah, it's actually, sorry, negative 5. Ooh.
I won't be too much of a sticker over it.
No, it's actually very important. It has to be negative.
Alright, fair enough.
Alright, okay. F of g of x, so there's no variable, so we know we're going to need a domain. So we plug in g of x into f, so 3 over, use a different color, x minus 2 squared minus 5. That equals 3 over x minus 2 minus 5, which equals 3 over x minus 7. And then our domain is, we can't have this thing negative in here, and we can't have this equals 7 because we can't have a 0 on the bottom of a fraction. So our domain is going to be 2 to 7 and 7 to infinity. So I'll make a note right here. So domain has to be above 2 because we can't have a negative square root, and it can't be 7 because we can't have 0 in the denominator. Do a little star here. Alright, and then finally f of g of 0. So we have, we're going to start with g of 0. We have square root of 0 minus 2 equals square root of negative 2. Well, we already noticed that we weren't allowed to have square root. So this one actually does not exist. Alright, this one is a little trickier, but it's really important. So decomposition of functions. So this is the opposite. This is like you are breaking down functions. You're trying to figure out which parts go with which parts, right? Okay, so that'll make more sense as we do it. Okay, so we're saying h of x equals f of g of x. So h of x is some random function that is comprised of two different functions, and one of them is inside the other. Okay, so it's easier to try and think of the outside function first. So if we know that h of x is square root of x cubed plus 1, we can say, okay, f of x is the outside one, right? So we go right here, f of x outside, g of x inside. And this, If you haven't noticed, this isn't always the case. This isn't always G is inside, F is outside. It depends on the order, right? So in these three examples, it was always G on the inside. But in this example, it was F on the inside. So it just depends which way they write it. Okay, so we know that F of X is on the outside. So we're going to make F of X the square root of X. And then we're going to make G of X whatever is inside. So G of X is going to be X cubed plus 1. Nice, yes. So if we were to just double check, right, we have H of X equals F of G of X. And we can see, okay, yeah, it'd be the square root of X cubed plus 1. So this is really important to be able to go forward and backward with functions. We want to do composition of functions and decomposition of functions. So if we look at another one over here, we want the outside, we can make it 1 over X, and then we can make G of X.
It would be X squared, right? Or
it would be X squared plus 1. Yes, nice. Right? So this is pretty much saying, okay, this is what I want the outside to be, and then this is saying, instead of X here, I'm going to plug in this whole new thing for X. For operations of functions, you just rewrite it sort of like algebra. So addition, we have F plus G. Subtraction, we have F minus G. Multiplication, we have F times G, or FG, like just next to each other. And then dividing, we have F divided by G. We can also write it, there's different forms to write it, sort of like we saw above. So this would be F plus G of X, F minus G of X, FG of X, and F divided by G of X. And then this, you could see an example with an actual number, right? So we could have F plus G of 2, F minus G of 4, FG of negative 3, F divided by G of, 4.78, right? So there's a ton of different examples where you're solving at a point and then just solving in general. So, right, this one I could be like, evaluating, I guess. Evaluating at a specific value. And this is just like still with variables. Okay, so with some examples, will make a little more sense. So we have f of x given and g of x. G of x is going to be 3 minus 5x. And we want to find f plus g of x. So it's simple as just adding. So we have f of x equals 2x squared minus 1 plus g of x plus 3 minus 5x. We can use our parentheses to be more careful. So if we combine this, right, we have 2x squared minus 5x minus 1 plus 3 is going to be plus 2. And our domain, there's no restrictions on the domain. There's no fractions or anything. There's no square roots. So we can say it's negative infinity to infinity or all real numbers. And then for multiplication example, we're going to multiply them. We're going to use however you want to multiply binomials. So you could do box method, you could do double distribution, you could do FOIL. It's all the same thing. I'm just going to do FOIL. So we have first, we have 6x squared outside minus 10x cubed inside minus 3, and then last plus 5x, right? This becomes a positive. So we rewrite this in standard form. We have negative 10x cubed. Let's start with the highest exponent at first. Plus 6x squared plus 5x minus 3. Our domain, again, doesn't have any restrictions. So we're going to do negative infinity to infinity or all real numbers. So just got to be careful with multiplication. You do all the steps. And then standard form, remember, it starts with the highest degree. Okay, subtraction. Not that difficult at all. You just got to be careful with the signs as always. So we have 2x squared minus 1 minus 3 minus 5x. So we have 2x squared minus 1 minus 3 minus negative becomes a positive plus 5x. Write it in standard form, 2x squared plus 5x minus 4. Our domain is again all real numbers. And then finally f divided by g. So we have 2x squared minus 1 over 3 minus 5x. For the domain, so this is already simplified. We can't really factor this any further. So this is already, we've already combined like terms. We've already canceled out anything that needs to be canceled. The trick is our domain right here, right? So we can't have 0 on the denominator. So for our domain, we're going to figure out what would make that happen, right? So we have 3 equals 5x, x equals 3 over 5. So if x were to equal 3 over 5, then something would be wrong with the denominator. So pretty much we can say our domain, the easy way of saying it is x is not equal to 3 over 5. But if we were trying to be like in interval notation, we could do negative infinity to 3 over 5, and then 3 over 5 to infinity. Okay, so now we're going to do an example, but at a specific point for this one. And then we're going to do another division one. Okay, so we have f plus g of 2. So you could do two things. You could either combine it and then put in the point, or you could put in the point and then combine it. So I'm going to do both ways. I'm going to do combine first, and then like with value first. And you'll get the same answer. Okay, so combine first. We have f plus g, so we have root x plus 5 minus x. And we can't really combine like terms. So then we're just going to plug in our 2. So we have root 2 plus 5 minus 2, root 2 plus root 3. And then here we're going to do our value first. So we're going to do root 2 plus root 5 minus 3. And then we know that we add them. Sorry, that's minus 2. So this one, it didn't seem to be much different, but sometimes it really does make a difference if you put the value in first or if you combine it first. Usually it's easier if you put the value in first. So our domain, it doesn't really matter for this specific example because we're evaluating at a point, so we're going to cross that out. We only want domain when there's like an x here. Like in the previous example, right, there's like an x, or there's like no value. If it's at a specific point, you don't really need to worry about domain. Okay, we have f divided by g. So we have root x over root 5 minus x. Can't really simplify that any further. So we can't have the top radical be negative, right? So top can't be negative in the radical. So for the top, we have x is greater than or equal to 0. Bottom, same thing. That little quote just means same thing. You can write it again. So x has to be less than or equal than 5. And then denominator can't be 0. So x has to be less than 5. So it can't be equal to 5. It has to actually be less than 5. So pretty much we have x is greater than or equal to 0 and then less than 5. So our domain would be 0 to 5. So this one had lots of different rules, and then we had to combine them all to make one rule. Okay. Okay, the last is graphically. So we're going to take the same concepts, but think of how it applies to a graph. So we have, I'm going to use highlighter just to make it easier. So we have F is blue, and then we have G is yellow. So we have F plus G at 2. So we're gonna let's do this separately. So we have maybe over here. F of 2, G of 2, F of -1, G of -1, G of 0, F of 0, F of -2, G of -2, G of 3. Okay, so we're just going to find the different parts of it. So F is our blue. F of 2 is 0. F of -1 is 3. G of 0 is 0. G of 2 is -1. G of -1 is -2. F of 0 is 4. Okay, we start with these three since I sort of jumped all over the place. Okay, so we found F of 2, we found G of 2, and we need to add them. So 0 plus minus 1 is equal to -1. F of -1 minus, right? So we can write this as like F of -1 minus G of -1. So it's the same thing as 3 minus -2. That's going to equal 5. And then we have to times these two. So we have G of 0 times F of 0, which is the same thing as 0 times 4 equals 0. Okay, so for this one, we have F divided by G of -2. So F of -2 is 0, and then G of -2 is -4. So we have 0 over -4. 0 over anything is just 0. So this one we're doing composition of functions, so we have to do the inside first and then the outside. So we have the inside, which is G of 3. So G of 3 is -1. And then we do F of -1. And then we hop to the other graph. F of -1 equals 3. So this one's a bit trickier. It's not just adding, subtracting, dividing, multiplying. We have to take the inside of one and then put it into the other. Right, so we found G of 3 first, and then we took that answer and we put it, and we found where it was at F. Okay, now we have F plus G. So this is really tricky. We actually have to find a rule. So to come up with this graph, let's graph it, right? So we have X, F plus G of X. So we have X, we have -2. -1, 0, 1, 2, and 3. That's the entire domain of this function. So if we add them, right, let's start over here. So we have 0, -4, -2, and 3. That becomes +1. At 0, we're adding 0 and 4, so we have 4. At 1, we have -1 and 3, so we're at 2. At 2, we have 0 and -1, so -1. And then at 3, we have -1 and -5, so that becomes -6. So if I was to graph this, we'd have -2, -4, 1, 4, and then we have 1, 2, 2, -1, and 3, -6. So the graph would be sort of weird. It would look something like this. So yeah, it would be hard to figure out the function of that graph, but this is essentially what the graph would be if we combine the two, right? If we added the two,